So hello people, today we'll be solving LeetCode daily question 310, that is minimum height trees, and on this we'll be given a tree which is an not a binary tree or an m-array tree. It's basically an m-array tree, sorry. And the tree is an undirected graph in which any two verses are connected exactly by exactly one path. And in other words, what we can say is that any connected graph without simple cycles or any cycles is called a tree. Okay, so what we have to do is we have to return the minimum height trees, and in this what we are be having is we'll be given a tree of n nodes labeled from 0 to n minus 1 and an array of n minus 1 edges, where edges I represents edge ai bi, which represents there are two nodes ai and bi, and there is an undirected edge between them, and we can choose any node of the tree as the root. And when we select a node x as the root, the result tree has a height h, and among all the possible root trees, we those with the minimum heights are called as minimum height trees. And we have to return the list of all minimum height root labels, and we can return it in any order. Okay, so first let's say if we are having 0 as the root, so the minimum height which we can achieve is of 2. Okay, but if we are having 1 as the root, so the minimum height is 1. If we are having 2 as the root, so again our minimum height is 2, our height is 2. And then 3 if we are having, again our height is 2. Okay, so in that case we'll be returning only 1, because only 1 is as a node, in which if we keep it as a root node we'll be getting the minimum height. Okay, so for this, firstly let's what we'll have to do is we have to create a basically the tree. So for this we'll have a answer list also, in because we need to return answer list, that is equal to new array list. And what we'll be doing is we'll be using we'll be checking that if my n is equal to 0, that means there is just one node. Oh sorry, if n is equal to 1, or let's say if edges length is equal to 0, edges dot length is equal to 0. So in this case what we have to do, we have to do answer dot add 0, because that will be the only possible node, and we have to return the answer list. Okay, else if this is not the case, what we'll have to do is we'll be calculating the n degree of the particular nodes. Okay, because we know that a root tree like the root node will not have any n degree, so that will be equal to new int of size n. Then we'll also have a hash map to create a tree. Just a map of integer comma list of integer, that will be equal to tree, that is equal to a new hash map. Okay, and now what we'll be doing is that for every int I equal to 0, I less than n, I plus plus, what I'll be doing is I'll be adding like tree dot put I comma new array list corresponding to that array list. Okay, and then for int edge in edges, what I'll be doing is I'll be doing the firstly in degree of edge 0 plus plus, and in degree of edge 1 plus plus. And then what I'll be doing is that map dot sorry, not map, tree dot get edge 1 edge 0 dot add okay, not newer list, edges 1 edge 1, and I'll just copy it. Here I'll be adding edge 0 and here edge 1. Okay, so we have created the tree as well, and now we'll be using a queue of integer that will be for BFS to calculate the height, that will be called a new array list. And BFS is nothing, just level order traversal, so we'll be like checking how deep we'll go from a particular node. Okay, and also not we can use the arrays as well, but I'll be using a linked list. Okay, now we'll be checking that for int I equal to 0, I less than n, I plus plus, and then sorry, yeah, what I'll be checking that if in degree of I is equal to 1, that means that is the root, as it's like if the integer is 1, in that possible case only we are having we can take it as a root, in other cases we don't. Okay, so if integer is equal to 1, what I'll be doing, I'll bfs dot offer I, and then while not bfs dot is empty. Okay, and now let's also have the level variable and count is equal to 0. Okay, and we'll be doing int size, that is equal to q dot size, bfs dot size, and we'll be increasing the count plus equal to size, then a for loop that for int I equal to 0, I less than size, I plus plus, and from here we'll be checking the basically the integer. Let's have the node that will be equal to bfs dot poll, and we'll be doing the int degree of node minus minus. Okay, and now we'll be checking that if my count is equal to n, uh, if my count is equal to n, that is all the nodes have been visited. So what I'll be doing, I'll be doing list so answer dot add my current node. Okay, then what I'll be doing is that for int node n, and then tree dot get so let's do child instead, child in tree dot get node. Firstly what I'll be doing is if I'll be checking that if int degree of child is not equal to 0, I'll be doing int degree child minus minus, and then what I'll be doing, I'll be doing if int degree of child becomes 1, in that case I need to do bfs dot offer the current child. Okay, and at the end I'll just have to return the list, return list. Okay, so now let's run it. It's answer not fungible in degree. Okay, so oh, in degree array. Now let's run it. Yeah, and it gets accepted. Now let's submit it, and it works perfectly fine. Okay, so this was it for today. Thank you for watching.